Hello and welcome to the second part of the TekTalk mini-series on how to make the Internet of Things more secure with HPE security solutions. This time we are going to talk about security analytics and malware. My name is Angelo Brancato and let's get started. In the last session, we laid the foundation for IoT security and touched on the different HPE software solutions to build, test, deploy, and operate secure IoT applications. We also took a closer look on how to implement end-to-end data security with HPE Voltage Secure Data. As this session is based on that foundation, I encourage you to go back and watch the first part if not done yet. In this session, we will be focusing on security intelligence and HPE Security ArcSight. HPE ArcSight is a solution portfolio offering a whole set of IT security capabilities, and there will be more Tech Talk sessions on these. But if I were to summarize what ArcSight does in one sentence, then I would say it takes away what attackers need most, and that is time. Time to find the valuable assets within the corporate network, and either exfiltrate or monetize this stolen data, or to destroy that asset. History and experience told us the hard lesson that it is not the question if adversaries break into our network, but when. The rule of thumb, unfortunately, is if I have valuable assets in any form, a breach is inevitable, especially in highly complex and interconnected scenarios like IoT. But the breach is not the issue. The issue is if we give them enough time to cause damage. And so we have to detect threats in real time and neutralize them. If we manage to do that, we win. And the only chance to achieve that is to look at the log data throughout the entire infrastructure. Because no matter how sophisticated or persistent or advanced an attacker may be, it will always leave tracks in one form or the other. And ArcSight is market leading in triggering and alerting on these tracks within the log data in real time. When considering finding these tracks or patterns within the data, it is helpful to consider a river delta as analogous to the enterprise security landscape. A river delta consists of streams that lead into rivers that lead into the ocean or a big lake. Streams of log data are generated by the IT infrastructure around the clock. Common log sources can be hosts, applications, users, network and security infrastructure components, and of course all IoT endpoint and edge computing devices. Let's call this the tactical level, because on this level there are many enforcement points like firewalls and intrusion prevention systems that could block the attack if we were aware of the attack. And awareness is gained in the operational level. Let's see how that works. So, the event data flows downstream and is aggregated into rivers of enterprise log and security data. And here's where we can apply real-time correlation of known attack patterns. In other words, if we know what we are searching for and what chain of events and dependencies must be given in order for it to be an anomaly or an attack pattern, we can put that into deterministic rules, load them into memory and apply them all at once to the data flow to get real-time alerts. And that's exactly what HPE ArcSight Enterprise Security Manager does with hundreds of predefined and custom correlation rules. And in a perfect world, that would be enough to detect all possible attacks. But unfortunately, nothing is perfect, and adversaries are constantly evolving their attacks. And so there is many evidence that flows unnoticed past the operational level into the data lake because, quite frankly, we didn't know what to look for. And this is where big data analytics comes into play. Data scientists, or often also referred as the hunt team, will deep dive into the data lake and try to make use of all that data that lies dormant otherwise. They will pivot through the data like a fisherman throws his net overboard. They will cluster and aggregate what they find. They will build affinity groups where relations fall into place. They will do statistical analysis, train models, use machine learning, and detect outliers across any of the enterprise data feed. In other words, it's not easy to find the unknown. Once new indicator of compromises are found though, they need to be communicated as fast as possible to the operational layer, where they are converted into automated real-time detection correlation rules. And if these rules trigger, the tactical level needs to be informed as fast as possible also to enforce that newly learned pattern and remediate the attack. In this session, we will look at a very specific aspect of security analytics and focus on finding indicator of compromise for malware-infected systems. But don't worry, we will not do applied data science, but we are going to take a look at a ready-made solution that will find malware-infected hosts automatically. You can think of it as a hunt team in a box. And that solution is called HPE ArcSight DNS Malware Analytics, or DMA. The basis for DMA to find malware-infected hosts is the Domain Name System Protocol, DNS, because basically that is the common denominator for any malware. At some point, every malware tries to communicate back to its mothership or command and control server in order to be remote controlled or to receive instructions, and DMA will detect that pattern in the DNS requests. So, analyzing DNS can be a very efficient way to detect attacks and malware. But at the same time, for most enterprise environments, it's a real problem to turn on logging for DNS, simply because of its sheer volume. Within HPE, approximately 18 to 20 billion DNS packets are processed by our 6 core DNS clusters every day. And turning on logging on the DNS servers would have a severe performance impact on them. And let alone the performance impact. For a SIEM to ingest that kind of event volume, it would have to expand by almost an order of a magnitude. And even if we did turn on logging and ingest all the logs, we would not get all information, like all DNS reply information. For example, it is very typical for malware to query many non-existing domains, where the DNS server sends back an NX domain record. And this is why we not only developed DMA as an answer to that problem, but we, HPE, are also using it very successfully internally for the last 3 years now. Now let's get an understanding of how it works and how it can detect and remediate malware in an IoT environment. The DMA solution consists of 2 core components. The first one is the DNS capture module, which is a pre-configured and hardened HPE appliance that is installed on the local network. For example, in the IoT Cloud Platform data center. It will then get all DNS traffic mirrored via one or more network taps. The DNS traffic is pre-analyzed locally on the capture module, and only a digest of the suspicious traffic is sent securely to the second DMA component, which is the multi-tenant HPE Analytics Cloud. In general, the DNS capture module is able to pre-process the DNS data so that in average only 1% of that data needs to be sent to the DMA cloud for further machine analysis, which is working 24/7 and is based on the HPE Vertica Big Data Analytics platform. If DMA finds infected hosts, it can report them back immediately to ArcSight ESM via a REST connector and a secure TLS channel. Now, if we were to have infected IoT components and through the described analytics and operations entities working hand in hand, we get immediately alerted. ArcSight ESM is also able to initiate a remediation action to an external system. That external tactical system could be the HPE Aruba ClearPass Policy Manager, which could get the instruction from ArcSight to push certain hosts onto a quarantine VLAN so that they can be remediated. So we can say that DMA is a system that will find malware-infected hosts on the network with a very low false positive rate, because if those hosts are behaving like malware, there is malware on it. It also implements the analyst in a box concept for that specific big data security analytics use case. And it will deliver benefit from day one on and find unknown indicator of compromise where signature-based systems are unable to trigger on, because there is no signature yet. Okay, now let's talk tech and see how we can find and remediate malware with HPE ArcSight DMA in a live demo. First, we log on to ArcSight Enterprise Security Manager, because that is our single pane of glass for security operations, and we jump right into an active channel that displays all alerts coming from the DNS Malware Analytics Cloud via the REST connector. By clicking on Visualize Events, we create a visualization where we immediately can see an overview of all infected hosts and IoT endpoints, 6 in this case, and the corresponding type of infection that got determined by DMA. If we need more information about the infected hosts, we can open the DMA web interface and browse through the data to learn more about the infection and the behavior of the malware. On the dashboard, we can see the 6 hosts that we saw in ArcSight ESM with the top malicious domains that they accessed in the past. Each infection is also mapped to a category or type of malware due to its behavior and due to what DMA found out by analyzing the DNS traffic. In the alert section, we can also see the pattern that a specific malware used to communicate to the outside world, to, for example, communicate to the command and control server, or using DNS for tunneling and exfiltrating data to an external system. By clicking on a specific host, we can also inspect each and every malicious domain that this particular host tried to access. As described before, to implement automatic remediation, we want ArcSight to trigger an API call on the Aruba Policy Manager to quarantine the specific infected host. To do so, we go back to ArcSight ESM and launch the rich Java console. Here we see the exact same active channel that we saw on the ArcSight ESM web interface earlier. But this time we want to create a correlation rule that will trigger each time a DMA alert comes in from the DMA Analytics Cloud. We give the rule the name DMA Aruba Quarantine Host. This is just an exemplary rule, and it should always trigger when a DMA alert comes in, so we just grab the DMA device product identifier from the Ceph event and add it to the rule event condition editor. Then, and this is the important part, whenever this rule triggers, we want to execute a command. The command is a Python script that is installed on the ArcSight ESM server itself, and it will authenticate against and call the Aruba REST API to quarantine the specific IP address in the event, which is the infected host. With the described solution, we not only reliably detected hosts in our IoT environment that were infected with malware through analytics, but we also built an automated bridge into the operation layer and remediated the threat before the attacker achieved his or her goal. And with that, we win. Today we discussed how to find and remediate malware in enterprise and IoT environments through automated analytics. Stay tuned for the next Tech Talk on how to make the IoT more secure. Thanks for watching. Ciao.